I'm Anil Kumar. In this series of trigonometry, we'll concentrate on very basic concepts. In part 1, we'll discuss trigonometric ratios of acute angle. We'll develop all the formulas and try to do questions without the use of calculator. In many tests, calculator is not allowed when you begin with trigonometry. So trigonometric ratios are basically defined in a right triangle. So here is one right triangle. Let's call this triangle by the name OAB. So I'll call this vertex as O, here A and B. The angle, the acute angle at O, let it be angle theta. You'll find that most of the angles are written in Greek letters alpha, beta, gamma, theta. They could also be written as angle BOA or angle AOB. Now trigonometric ratios, which are primary trigonometric ratios, are basically sine theta, cos theta and tan theta. So these are primary trigonometric ratios. Sine theta is a ratio of opposite side to hypotenuse in any triangle. So in this particular case, it will be AB over hypotenuse OB, right? Cos theta is adjacent side, which is OA here, over OB, and tan theta is opposite over adjacent, which is AB over OA. To remember this particular formula for trigonometric ratios, in North America they use SOHCAHTOA. So S is for sine, opposite over hypotenuse. So this becomes the opposite side. Let me write opposite. And this is hypotenuse. As far as tan is concerned, or cosine is, let me write cosine first, SOHCAHTOA. So for cos, they write cos is adjacent over hypotenuse. So this side is called adjacent side. Let me write down the same ink, adjacent. Adjacent over hypotenuse, this ratio. And as far as tan is concerned, tan is written as opposite over adjacent. So that's the acronym to remember the ratios sine, cosine and tan. Now, we also work with reciprocal of these ratios. So reciprocal of sine is cosecant theta. So in short, it is written in cosecant, which is 1 over sine theta. Secant theta is 1 over cos theta, and cotangent theta is 1 over tan theta. So of course that become cosecant will be hypotenuse over opposite, secant will be hypotenuse over adjacent, and cotangent will be adjacent over opposite. So these are 6 ratios with which we will normally be working. Now if I take the same triangle in a coordinate plane, so let me make a coordinate plane and consider a point P with x and y coordinates. So I'll do one thing here. I'll just sketch a coordinate plane, and we are considering all angles in the first quadrant. So we're considering acute angles, right? So acute means less than 90 degrees. So let us say we have a point P here, and the coordinates for point P are x and y. It really means that if I drop a perpendicular from P to the x-axis, then this length here is x, and the height here is y. Correct? This is the y-axis. Now, if I say this angle is theta, as we have taken here, and the distance from O to P using Pythagorean theorem, let's call it r. Using Pythagorean theorem, we can write r is equals to square root of x square plus y square, right? So you can find r, the hypotenuse of this triangle. Now, in case a point is given in a coordinate plane, then you can again write these ratios as sine theta equals to, opposite side is y over hypotenuse, which is r, as y over r. Cos theta is x over r. Tan theta will be y over x. These ratios, cosecant theta will be r over y, so just flip them, right? R over y. Secant theta will be x over secant will be x over r over x, reciprocal of cosine, and cotangent will be x over y. So that is how you can get the ratios if any coordinate point is given to you. So as an example, what you can do is you can consider a point P whose value is, let us say, 3, 4. Find all these trigonometric ratios, and in this let us consider a triangle. Let me make one here whose sides are, let's say theta is the angle, and whose sides are, let us say 12, 5 and 13, right? That becomes a right triangle. Now write down all the ratios as an exercise. Now let us see how these trigonometric ratios are related. So we'll use a simple Pythagorean theorem to derive relation between sine and cosine. So let us consider this particular triangle here, OP, and let me call this point as, let's say, Q. So in that case, x square plus y square is r square. Since it is a right triangle, I could write here as x square plus y square equals to r square. Now if I divide all of them by, let us say, r square, what do I get? If I divide all of them by r square, x over r is cosine theta, right? X over r is cosine theta. I could write this ratio as cos square theta. Y over r is sine theta, so I could write this as y square over r square as sine square theta, and r square over r square is 1. So we get a ratio which relates cos and sine. So sum of squares of cosine and sine is 1. Do you get it? Now, if I divide the same ratio, x square plus y square equals to r square, the Pythagorean combination of the sides of a right triangle, with instead of r square, let us say I divide by x square, then what happens? X over x square is 1 plus y over x. So y over x is tan. So we get 1 plus tan square theta, and this is r over s, which is secant square theta. So we get another Pythagorean identity for trigonometric ratios. 1 plus tan square theta equals to secant square theta. Now if I divide it by y square, what do I get? So x square plus y square equals to r square to begin with. Dividing all three by y square gives us x over y is cotangent, right? X over y is cotangent. So it's cot square theta plus 1 equals to r over y. So reciprocal of sine, which is cosecant square theta, correct? So here, as you have seen, we have derived three very important relations between trigonometric ratios from Pythagorean identity, right? So they are also called trigonometric Pythagorean identities. They are always true, correct? So that is a very important derivation to understand. Now this really helps us to find sine if cos is given to us, or cosine if sine is given to us, and things like that. Now let's take up a question. So let us consider a point which is given to us. So let's do this question here. So let's say we have a coordinate point P whose value is, let's say, 3, 4. Now we have to find all the ratios where the coordinate point is 3, 4. So if this is the point which is 3, 4 for us, in that case, the angle theta could be written in terms of the sides of this right triangle, which are 3 is the horizontal distance, which is adjacent side, 4 is the height. Now here radius r, r the hypotenuse, will be equals to square root of 3 square plus 4 square, which is 9 plus 16 square root. So we find that r is equal to 5. Since r is equal to 5 units, we can write that sine theta is equal to, let's take another. Sine theta is 4 over 5. Cos theta is 3 over 5. Tan theta is 4 over 3. And reciprocal of these, you could just flip them and write those values. Now as an exercise, what you can do is you can verify these results. Are they always true? Using these points. So that could be an exercise. Now soon we will learn how to find the angle theta. Now, since in this particular part 1 we are not using calculator, so I'll just write for you that theta could be calculated from any of these above primary trigonometric ratios. If tan theta is 4 over 3, then theta will be equals to tan inverse 4 over 3. So we'll learn this part at a later stage. Okay? So theta could be calculated from any of these ratios. Just as I've shown you here, theta could be calculated as tan inverse of angle of the ratio 4 over 3. Right? So these ratios will give you a number, and as you can see from here, what is the maximum and minimum value of each ratio? So let that be a question for you. So a question for you here is, what is maximum and minimum value of sine theta or cos theta? Now as you can see here, sine theta is a ratio of smaller side over hypotenuse. Do you see that? Smaller side over hypotenuse. So the maximum value could be just 1. So it cannot be more than 1. Right? Now we are concentrating on the acute angles in quadrant 1. If, however, we have this triangle in some other quadrant, then you will realize that the y value could be negative. So if y value is negative, in that case, sine theta and cosine theta can also have negative values. Same is the case with tan theta, correct? So as you can see in this particular case, the value of sine theta and cosine theta is always within plus and minus 1. So what you will notice here is that sine theta is less than equals to 1, and it is always greater than equal to minus 1. Same is the case with cos theta. So cos theta also will be less than equal to 1 and greater than equals to minus 1. However, for tan theta can have all values. Since the ratio of these two sides could be anything, right? So tan theta will belong to a set of real numbers. It could have any value, right? So now in the next part, we will learn very special triangles and then also see how to calculate angles from those situations without using calculator. Now we will consider few special triangles. One of them is 90 degrees, 45 degrees, 45 degrees. The other one we call it as 30 degrees, 60 degrees, 90 degrees. And then we'll talk about 0 degrees and 90 degrees triangles. Okay. So to begin with, let me sketch one which has these angles. Sum of three angles of a triangle is always 180. So let's consider an isosceles right triangle with side lengths of 1 and 1. So the hypotenuse will be 1 square plus 1 square square root, right, which is square root of 2. So that is a special triangle with angles of 45 degrees, both angles of 45 degrees, and that is 90 degrees. Now in this particular triangle, you can write the ratios. Sine of 45 degrees as 1 over square root 2. Cos of 45 degrees as also 1 over square root 2. Tan of 45 degrees will be 1. These two sides are equal. You could also write ratios for the reciprocal of these, which is secant, cosecant, and cotangent. Correct? So that means secant, I should write secant here. Secant 45 degrees is square root 2, and this is cosecant. Reciprocal of sine of 45 degrees will be equals to square root 2, and cotangent 45 degrees will be 1. Easy way to remember that is SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Perfect. Now let me consider the second triangle, which is 30, 60, 90 triangle. To make this, we actually begin with an equilateral triangle. So here is an equilateral triangle. If I drop a perpendicular, then it will bisect the other side. So let us consider equilateral triangle of sides 2 units. Half of 2 will be 1. If that is a perpendicular, this side will be 2 square minus 1 square, right? So this side will be square root of 3, which you get as square root of 2 square minus 1 square, which is square root of 4 minus 1, so you get square root of 3. The angles are 60 degrees, that is 90 degrees. So this angle has to be 30 degrees. So this triangle actually gives us trigonometric ratios for both 30 and 60 degrees. Do you see that? So you can just pause the video, write down what is sine of 60 degrees, what is cosine of 60 degrees, what is tan of 60 degrees, and also write down what is sine of 30 degrees, what is cos of 30 degrees, and what is tan of 30 degrees. Correct? When you say sine of 30 degrees, go for SOHCAHTOA. Opposite. So opposite side is square root 3, hypotenuse is 2. So we get square root 3 over 2. For cos, half. This is 1, right? 1 over 2. For tan, square root 3 over 1. So you could write square root 3. Cos of 30 degrees, you have to look from that side. Now if I look from this side, the side opposite is 1, correct? So sine will be 1 over hypotenuse of 2. For cosine, it becomes square root 3 over 2. And for tan, it will be 1 over square root 3. You will notice here that cos of 60 degrees and sine of 30 degrees is same. Cos of 60 degrees and sine of 30 degrees is same. Do you see that? Also, sine of 30 degrees and cos of 30 degrees is same. In general, in any right triangle, if one angle is, let's say, theta, the other one will be 90 minus theta. You get a point, correct? So you will notice that in a right triangle, let me make one here. If this angle is theta, this is right angle, what is that angle equals to? It is 90 degrees minus theta, correct? So side which is adjacent becomes opposite when you look from the other side. That is the reason why, let me write down here, that sine of 90 degrees minus theta is equals to cos theta. Cos of 90 degrees minus theta is sine theta, and tan of 90 degrees minus theta should be equals to cotangent theta. Okay. because a triangle kind of flips if you see from the other side. This is a very important relation to remember, and we call them as co-function identity, right? So this will be referred to as co-function identity, right? So remember this, that when we're looking for 90 minus theta, sine becomes cosine, cos becomes sine, tan becomes cotangent. Now we'll look into very special cases when we talk about an angle which is 0 degrees. So let's work what is 0 degrees. Now if I try to make a triangle, let's say this is 0 degrees, let us say, right? So 0 degrees we are talking about, that really means that the opposite side equals to 0. Do you see that? And adjacent side is equals to hypotenuse. So in 0 degrees, that is a special case. If that is the case, then what is sine of 0 degrees equals to? What is cos of 0 degrees equals to? And what is tan of 0 degrees equal to? Since opposite side is 0, sine 0 will be 0. Since adjacent and hypotenuse are same, cos 0 will be 1, and tan is opposite over adjacent, 0 over anything is 0. Do you get it? So that is a very important thing to remember. For 0 degrees, sine is 0, cosine is 1, tan is 0. Now what happens when you consider 90 degrees? So if let's say that is my radius, right? So if I increase it and come to this place, that becomes 90 degrees. Now the triangle formed is kind of like this, where adjacent side is 0, and now opposite side is equals to hypotenuse. So in this case, what will happen? Clearly, as far as sine is concerned, sine of 90 degrees, since opposite is same as hypotenuse, it will be 1. As far as cosine is concerned, adjacent side is 0, so that is going to be 0. What happens to tan? Tan is opposite side over adjacent. So it is something divided by 0, so it is undefined. So tan is not defined for 90 degrees, right? So tan could have extremely large value, and it says infinitely large value, which is really undefined. So for 90 degrees, tan is undefined. You get an idea. So in this part of the video, we have learned about few triangles, and these triangles give us value for sine, cosine, and tan, and also for their reciprocals, which is, you can always find what is cosecant theta, what is secant theta, and what is tan theta for, so you make this table now for secant, cosecant, and tan. You can fill this up, right? For different angles, let's say the angles are 45 degrees, 30 degrees, 60 degrees, 90 degrees, and 0 degrees. Is it okay? So fill up these for the reciprocal of these angles. That should be a good exercise. So I hope you understand how with special triangles we can find angles and also the sides without calculator. Correct? So let's move on to our very special question, that is to find tan of 15 degrees. Now to find the exact value of tan of 15 degrees, I'll be using the special triangle. Let me sketch the special triangle here, which is 30, 60, 90. So most of the time we only need to sketch 1/2 of the triangle which we're talking about, 1, 2, square root 3, where the angles given to us are, this is 60 degrees and that is 30 degrees. So this is a special triangle which we are going to look into, right? So from this triangle you can always say what is tan of 30 degrees. So tan of 30 degrees will be opposite over adjacent. it is equals to 1 over square root 3. What do we need to find? We need to find tan of 15 degrees, right? That is what we need to find. That is the exercise we want to work for. So how do we begin? Here is a very interesting way of looking into it. So what I will do here is sketch a diagram first, and then we'll work on it. So let me take, I'm just thinking where to sketch it. We could do it here also, okay. So let's talk about a coordinate plane, and in this coordinate plane we will take up a point which represents tan of 30 degrees, okay. So we'll just take a point which represents tan of 30 degrees. That is, if I draw a line which is kind of at 30 degrees here. So I've taken 30 degrees here. Now to make our special triangle, I can take a point here whose coordinates are 1 and square root 3, where opposite side is 1. That is to say that if I drop a perpendicular from here, I want that to be 1, and this side I want this as square root 3. Does it make sense to you? It really means that that is possible if I have a coordinate point here whose coordinates are square root 3 and 1. Let's call this point as point Q. Here is the origin O. Do you get the idea? Correct? So we now have a triangle. Let's call this as OQ. Let's call it M. Okay. How does it matter? So that's the right triangle. So we have a triangle here whose angle is 30 degrees. Tan 30 is 1 over square root 3. So the coordinates of this point will be square root 3, 2. What is OQ equals to? Okay, let's find what OQ is. So we say OQ is equal to square root of, it's a longer side, hypotenuse, 1 square plus square root 3 square, which is 3, and that is square root of 4, which is 2. So OQ is actually 2 units long. Correct. So OQ is 2 units long. So we get OQ as 2 units. Now, let us consider a point which is on 2 units on the left side. So that is on the coordinate plane, let's say it is 2 units here. So if I take this point on the left side of O 2 units away and join the point Q with this, what happens? Let us call this point as point T. Now, since these two sides are equal, that means that the angle here is equal to the angle there. Correct? So what we see here is that in the triangle OQT, OT is equals to OQ, and both are equals to 2 units. That means that the angle OTQ should be equal to the angle OQT. Perfect. Now since 30 is an exterior angle, 30 degrees is exterior angle, that is sum of 2 remote interior angles. Perfect. You could do like that. Perfect. Yes. So we know exterior angle is equal to sum of remote interior angles. Yes. That means 30 degrees is equals to these two angles. Let's call them alpha, right? So this is, both are alpha. So 30 degrees is alpha plus alpha. So 30 degrees is equals to 2 alpha, and alpha equals to 30 over 2, which is, let me write 15 degrees here. So we get alpha as equals to 15 degrees. So what we learned just now with this exercise is that by taking this point, we could get the angle 15 degrees at a point T. Correct? You could do the other way also, which is the alternate will be, let me write down alternate solution. If you don't remember this part, okay? The alternate solution is, what is that angle? So alternate solution is that angle TOQ is equal to 180 degrees minus QOM, which is 180 degrees minus 30, 150 degrees, correct? So this is 150 degrees. Since we're talking about isosceles triangle, sum of these two angles, that is 2 alpha, should be equals to 180 degrees minus 150 degrees, that angle, correct? So alpha is equals to, this is 30 divided by 2, which is 15. So that is the alternate method you could apply to get angle 15. Now the big question here is, what is tan alpha? Which is tan 15 degrees, since alpha is 15 degrees. So from this triangle, can you write down what is tan 15 degrees? Well, tan 15 degrees, look into the triangle. Let's do the work here. We look into the triangle TQM. Now what is tan? Tan is opposite over adjacent. Do you see that? So side opposite to 15 degrees is 1. And adjacent side is how much? Add these two. 2 plus square root 3. Do you see that? 2 plus square root 3. And therefore, we get that tan of 15 degrees is equals to 1 over 2 plus square root 3. So we can write down our answer. Tan 15 degrees is 1 over 2 plus square root 3. Since this base T to M, Tm is 2 plus square root 3. Correct? And Qm is 1. Their ratio is tan of alpha. Got it? So that is how, with very simple geometry, but a lot of work here involved, we could actually find measure of tan 15 degrees without the help of calculator, using special triangles and some tricks. So I hope that helps. I'm Anil Kumar. Feel free to write down your comments, share your views, and if you like and subscribe, that'll be great. In part 2, we'll take up compound angles and some identities. I hope that helps. Thank you and all the best.